All right, today we're working on the our test review for applications of derivatives unit. Question number 1, if x squared plus xy plus y cubed equals 0, then in terms of x and y, dy dx equals what? So we're looking for dy dx here. Obviously, we're doing a derivative. Notice or remember that whenever we have the x's and y's mixed up like this, we have to do implicit differentiation. So I'm going to start out doing the derivative of this function with x squared. Derivative of x squared is 2x plus the derivative of xy. Notice that that's a product, so I need to do product rule. So I'm going to do f times g prime. In this case, g prime would be dy dx plus g times f prime, which would be 1. And then moving on to the last term, derivative of y cubed is 3y squared, but y is a function, so I have to multiply times dy dx equals 0, and of course the derivative of 0 is 0. So when you're doing implicit differentiation, anytime there's a y and you take a derivative of y, you have to follow it up with dy dx, like I did in these two terms here. Now we want to solve for dy dx, because remember we want to know what it's equal to. So any term that does not have dy dx, I'm going to move to the other side. I can subtract 2x, and I can also subtract y. So now I have x dy dx plus 3y squared dy dx is equal to negative 2x minus y. Now that I have only dy dx terms on this side, I can factor out dy dx. I still have negative 2x minus y. And then last step, to solve for dy dx, it's being multiplied here, so of course we're going to divide. And if you look at our answer choices, you'll see that our answer matches answer A. That negative sign that's in the numerator, they factored it out to the front, leaving both of those positive. Answer A. All right, question number 2. The radius of a circle is increasing at a non-zero rate, and at a certain instant, the rate of increase in the area of the circle is numerically equal to the rate of increase in its circumference. At this instant, the radius of the circle is what? Now, when you first read this question, I know it sounds very confusing. So let's just go back in here and see what we know. This tells me that the radius of the circle is increasing at a non-zero rate. So that means that there is a dr dt, a rate of the radius, and it has to be positive. Then we have this statement, the rate of increase in the area. Okay, so my area has a rate, so we'll call that dA dt, is numerically equal to, okay, so I'm going to write equal, the rate of increase in its circumference. So my circumference also has a rate, which we would call dC dt. And the question is, at this instant, what is the radius? So when these two rates are equal, r equals what? That's our question. So even if you didn't understand what the question meant originally, hopefully if we can get this written down, you can see that we need to find dA dt and also dC dt. So I'm going to start out with the formula for area, which is pi r squared, and I'm going to take its derivative. dA dt would be equal to 2 pi r times dr dt. We just do power rule there. Remember, pi is a number. 2 just comes in front, we multiply 2 pi r. We have to follow it up with times dr dt because r, it has a rate, it's changing. I'm going to do the same thing for circumference. Circumference is equal to 2 pi r. It's also equal to pi d, but hopefully you realize we need to use the 2 pi r formula because our question here is about radius and not diameter. If I take this derivative, dC dt is equal to the derivative of 2 pi r would just be 2 pi, and then of course we need to follow that up with dr dt. So now I have these two rates, and there's some instant when they're equal to each other, so I'm going to set them equal to each other. And at that instant, I want to know what r equals. So down here, I need to solve for r. Here's my r. I want to get it by itself. So everything's being multiplied here. So I'm going to divide by 2 pi dr dt. Everything cancels. And over here, if I divide by 2 pi dr dt, everything cancels again. And so r must be equal to 1. Answer D. All right, question number 3. This is the one that's been giving a lot of us trouble. We need to write the equation of a line tangent to the curve, this curve that they give us at the point 2, -1. So remember, whenever you see tangent line, I want us to write out our formula. Y equals f of a plus f prime of a times x minus a. They're giving us a point here. You know, a lot of times on these questions they only give us an x, but in this instant we're given an x and also a y. Or in this case down here we're given the a and the value of the function at a. So for our equation, we know that y equals f of a, that's going to be -1, plus whatever my derivative is, which I don't know, x minus 2. And so even just getting this far, if you look at our answer choices, we can eliminate choices A and B because both of those have +2 in the parentheses and we know it should be -2. So now I'm just left with f prime of a. I need to find the derivative of this curve. So y squared, that derivative would be 2y, of course followed with dy dx, plus, now here's where this gets challenging. We've got a chain here because I have this function being raised to the 3rd power, but then within that chain we've also got product rule with the xy. I'm going to do the power of 3 first. That's the outside function. So 3 times xy plus 1 squared. Notice that the inside stays the same. We're only doing 3 and reducing the power by 2. So we've done that derivative times, now we're going to do the derivative of the inside. And the derivative of xy, that's a product rule, f times g prime plus g times f prime. And the derivative of 1 is just 0. And then this equals the derivative of 0, which is still 0. Now normally on an implicit differentiation question at this point we would move all the non-dy dx terms to the other side and try to solve for dy dx. But this gets a little hairy because this whole term here needs to be distributed into these parentheses. And so instead of doing all that algebra, remember that we have numbers for x and y. Once we've done a derivative, we can plug those numbers in, which should make our work a little bit easier. Y is equal to -1. We don't know what dy dx is. That's what we're looking for. Plus 3 times 2 times -1 plus 1 squared times, let's see, x is 2 dy dx plus y, which is -1. Now here's where we need to be really careful and not make mathematical mistakes. This is going to be -2 dy dx. In here, I need to work what's inside the parentheses first, then I'm going to do my exponent, then I'm going to multiply by 3. Remember your order of operations, PEMDAS, parentheses, then the exponent, then multiplication. So in the parentheses, 2 times -1 would be -2 plus 1. So in the parentheses here, this is -1. But then I'm squaring it, so it turns into +1, and then I multiply times 3, which would be 3. So all of this equals 3 times 2 dy dx minus 1 equal to 0. I'm still trying to get dy dx by itself. Notice that this 3 we have here, it needs to be distributed into this parentheses. So -2 dy dx plus 6 dy dx minus 3 equals 0. I can add these together and get 4 dy dx. I think at the same time I'm going to move that 3 to the other side, add 3 to the other side, because I'm running out of room on the screen here. And to solve for dy dx, we divide by 4. So dy dx is equal to 3/4. And so if I go back and look at my answer choices here, I have this one with negative 3/4, this one with positive 3/4. But I know from my equation that it should be a plus sign, and we came out with positive 3/4. So our answer is C. Question number 4. We have a person 2 meters tall walking directly away from a street light that's 8 meters off the ground. The person is walking at a constant rate and the shadow is lengthening at the rate of 4/9 of a meter per second. At what rate is the person walking? So this is a shadow problem, and hopefully you're reminded that that means it's going to be a similar triangle problem. Anytime we have a shadow problem, we're going to have similar triangles, and we need to write a proportion. So I'm drawing my picture here. The only numbers we can put on the picture are numbers that are not changing. The height of the pole is not going to change. The height of the person is not going to change. The person is walking, so this distance right here is going to change. I'm going to call that W for walking. And the length of the shadow is going to change, and I'm going to call that D for shadow, because I don't like to use S's because they look like 5s. So there's our picture. We also need to write the given and the wanted information. We know that the shadow is lengthening at a rate of 4/9 of a meter per second. So that means that the rate of the shadow, dt, is equal to 4/9 of a meter per second. And we want to know at what rate in meters per second is the person walking. So we're looking for dw dt. That's what we're trying to find. Once we have our given and our wanted in the diagram, the next step in these problems is to write an equation that relates these variables. Like I said before, this is going to be a proportional relationship. Anytime you have a shadow problem, it's a proportion. So I'm going to say that 2 over d is equal to, of course the 8 corresponds to 2. This is the tricky part. A lot of students want to say 8 over W, but we have to put 8 over the entire side of the big triangle. It's over W plus D. Now at this point we could do a derivative, but I would rather do a little algebra to make this a little cleaner, a little easier before we do a derivative. So I'm going to cross multiply. 2W plus 2D is equal to 8D. And I'm even going to combine my D's, get them on the same side. So 2W equals 6D. So now I'm ready to do a derivative. The derivative of 2W is just 2, but of course dw dt equal to the derivative of 6D is just 6 times dd dt. And final step, substitute and solve. So we don't know what dw dt is, but we do know that dd dt is 4/9. So I have 2 times dw dt is equal to 24/9, and we could divide by 2, and so we have dw dt is equal to 12/9, and that of course reduces to 4/3, and so our answer is D. Question number 5. The function f is given by f of x equal to x to the 4th plus x squared minus 2. On which of the following intervals is f increasing? So this is a flashcard question. F increasing, whenever you see that, I want you to think, what does that mean? What did we learn on our flashcard? And we're going to write it down. This means that f prime has to be greater than 0. So I want to know when f prime is positive, because that's what's going to make f be increasing. So this tells me I need to find f prime. So I'm going to find the derivative, 4x cubed plus 2x. And then whenever I'm looking for the positive or the negative, that means we need to do one of those number line sign charts. And in order to do that, I have to take my derivative and set it equal to 0 and find those critical numbers, the numbers where the sign possibly changes. To solve this, We have an exponent, so of course we need to factor. I'm going to factor out a 2x, and we have left 2x squared plus 1 equals 0. So that means if 2x equals 0, then x has to be 0, or 2x squared plus 1 equal to 0. But if you think about this, if we have x squared, this has to be 2x squared has to be 0 or some positive number. Anytime we square something, we end up with a positive value or 0. And then if I add 1 to that, I'm getting a value that's higher than 0. Another way to think about this is to think about what the graph of this looks like. This is a parabola that opens up, and it's being shifted up 1. And so that tells me again that this factor, this part of our equation, is never going to be 0. So my only critical number is x equals 0, because 2x squared plus 1 cannot equal 0. So this is the only critical number. So I'm going to do a sign chart with 0. And so I want to pick a number that's in this interval, like -1. I want to plug it into the derivative. So I'm going to plug it back in to this right here. Remember that we've already said that this part has to be positive. So if I plug -1 into this factor, then that comes out negative, and a negative times a positive would be negative. If I pick a number in this interval, like +1, plug it in here, I get a positive value times a positive value is positive. And again, remember, I'm looking for where f prime is positive. That happens on this interval right here, which corresponds to answer C, 0 to infinity. Question number 6. What is the minimum value of f of x equal to x ln x? Well, here's another one of our flashcards. Minimum, that means that f prime has to be less than 0. So that's an indicator that I need to find my derivative. So f prime is equal to, notice we have a product here, so I'm going to do product rule, f times g prime plus g times f prime. There's our product rule. And again, anytime we're looking for positives and negatives, we need to find the critical numbers. We need to find the zeros, because that's when our signs could change, is wherever there's a 0. So x times 1 over x is 1, plus ln x is equal to 0. ln x equals -1. And then remember, to solve a logarithmic equation, we're going to make both sides an exponent on the base, which in this case is e. So e to the ln x equals e to the -1. The e and the ln cancel out, and I have x equals e to the -1. Now I'm going to go back and look at a couple of things. You might be tempted to look at the answer choices, and notice our answer choice is not there. And honestly, I'm really surprised that it's not one of the choices, because usually they try to trick you with this. This is not our answer. The question said, what is the minimum value? I need to take this answer and plug it back into my function. But before I do that, notice that we have this choice. F of x has no minimum value. I need to determine if this is actually going to give me a minimum value. And so to do that, I need to do the sign chart. Whoops. So e to the -1 is our only critical number. If I pick a number that's smaller than e to the -1, such as e to the -2, if you think about this, e to the -1 is 1 over e. And so if I choose the value e to the -2, that would be 1 over e squared. My denominator is bigger, which means this fraction is smaller. So this would be a value that's in this interval. I'm going to plug this into my derivative, which is here. If I plug in e to the -2 for x, I get, I'm going to actually write this out, 1 plus natural log of e to the -2. Natural log and e cancel out, and we get 1 plus -2, which is -1. most importantly, it's negative. Then if I pick a number that's on this side of E, and this one is easy, we could pick, you know, a large number, 10, 52, whatever you want to pick. And if we plug it in, 1 plus the natural log of 10, well, I don't know what the natural log of 10 is, but I do know it's positive because I know what the natural log function looks like, and when x is 10, this is positive, and then I'm adding 1 to it. So I don't know what this is equal to, but I do know that it's greater than 0. So on this interval, we are positive. That means my function is decreasing and then increasing. So I do, in fact, have a minimum value. So my answer is not E. And you do need to take the time to confirm that whenever they're giving you that choice. Make sure this is going to be a minimum. So now the last step, I need to plug e to the negative 1 into the function. So f of e to the negative 1 is going to be equal to e to the negative 1 times the natural log of e to the negative 1. Again, natural log and e cancel out, and I get negative e to the negative 1, which could also be rewritten as negative 1 over e, which is answer choice C. All right, question 7. If f is the function given by f of x equals 3x to the 5th minus 5x to the 4th, what are the x coordinates of points of inflection? Inflection points. There's another flashcard. What does inflection points mean? This means that I need f prime equal to 0 and, this is important, changing signs. This is why I have you remember this part. So I need to find, first of all, I need to find the second derivative. This tells me I need a second derivative. So, excuse me. Okay, I don't know what's going on here. I hope that I am recording. Sorry, having a little technical difficulty here. So I need to find a second derivative. F prime is equal to 15x to the 4th minus 20x cubed. That's my first derivative. Second derivative, 60x cubed minus 60x squared. Now again, I want to know when this second derivative is equal to 0 and changing signs. So we need to set it equal to 0. I'm going to factor out 60x squared, and I'm left with x minus 1. So either x is either equal to 0 or positive 1. Now don't be tempted to mark answer D here, 0 and 1. We have to check for changing signs. So I'm going to do a number line, 0, 1. If I pick a number in this interval, say negative 1, I'm going to plug it into my second derivative, which is right here. If I plug in negative 1 here, it's squared, so it's positive. In fact, this factor is always going to be positive. We can just write that down. If I put negative 1 in here, I'm going to end up with a negative value. So positive times a negative is a negative. If I pick a number in this range, say 0.5, this term is still positive. 0.5 in here minus 1, this comes out negative again, and so for this interval we're also negative. Notice there's no sign change here, so 0 is not an inflection point because we have to have a sign change. Let's pick a number bigger than 1, like 2. This term is still positive. If I plug in 2 here, this factor comes out positive, and so it's positive. The only sign change happens here at 1, and therefore the answer is C. Final question, what are all values of x for which the function f defined by f of x equals x squared minus 3 times e to the negative x is increasing? Forgive me, this is not the final question, is it? We've got one more after this. But question 8, Increasing, so I'm looking for f increasing. Well, again, it's a flashcard. F prime greater than 0. That tells me I need to find the first derivative. Product rule, we've got two things being multiplied here. F times g prime. Derivative of e to the negative x is e to the negative x times the derivative of negative x, which would be negative 1. That's a chain rule. Plus g times f prime, which is just 2x. Anytime we're looking for the positive and negative, we need to find the critical numbers. So I find this first derivative and I'm going to set it equal to 0. Now this one looks a little bit scary to solve, but notice we've got two terms here and they both have e to the negative x. That means I can factor that out. And I'm going to go ahead and factor out the negative 1 with it as well. I'm going to factor out negative e to the negative x. If I factor that out from this term, I'm left with x squared minus 3. Now I factored out a negative 1, so that's going to change this sign because I don't have the negative over here. So that makes it minus, and then here I have left 2x because we factored out the e to the negative x, so I just have 2x left. So I'm going to rewrite that. X squared minus 2x minus 3, get it in the correct order. Now this is something that I can factor. X minus 3 and x plus 1. Now here's where our parent function knowledge really comes in handy. I have this factor out here possibly equal to 0, but I know that e to the x and e to the negative x, that function is never going to be equal to 0. E is asymptotic at 0, but it's never equal to 0. So when I'm looking for my critical numbers, I don't have to worry about this first factor. I'm just looking at these two, and x is equal to negative 1 or 3. So finally, I'm looking for where this is positive, so I need to do a number line. Negative 1 and 3. So I need to pick a number that's in this interval, and we could just pick a large negative number. Let's think about this for a moment, and maybe one way to think about it would be to imagine what this graph looks like. If I just have e to the negative x, well, let's start out with e to the x. Normal e to the x looks like this. If I do e to the negative x, that's going to reflect the graph over the x-axis. This is e to the negative x. But then I have negative e to the negative x, and so that transformation flips it over the y-axis, and so it looks like this. This is negative e to the negative x. So notice that this negative e to the negative x, this factor here is always negative. This is always going to be negative. So really I just have to plug into these two and remember to multiply by a negative. So again, let's go back to this interval. I'm going to choose negative 2. If I plug that into this factor, it's negative. If I plug it into this factor, it's also negative. So I have negative times negative times negative, which would be negative. If I pick a number in this interval, such as 0, this factor is always negative. 0 in here is going to give me a negative. 0 here gives me positive. So negative, negative, positive. That's two negatives, comes out positive. If I pick a number in this interval that's bigger than 3, like 4, again, this term is negative. A 4 in this factor gives me a positive value, and this one also gives me a positive value. So I have negative times positive, which is negative. I was looking for f prime greater than 0, f prime positive. So that's this interval right here, which corresponds to answer D. Now we're on the last question. Question 9. Consider all right circular cylinders for which the sum of the height and the circumference is 30 centimeters. What's the radius of the one with maximum volume? Okay, so we see the word maximum. F prime equal to 0, changing positive to 0 to negative. So I need to find a derivative, and I want maximum volume, so that means I really need a derivative of volume. So volume of a cylinder, area of the base times the height, which in this case would be pi r squared times h. But if I'm going to do a derivative here, I really just need to know something about the radius. The height is, I don't need the height in this equation. I need to replace it with something that involves the radius. So that's where this information comes in. The sum of the height and the circumference is 30. So I'm going to write that over here. Height plus circumference, which is 2 pi r, that equals 30. If I solve this for height, height is equal to 30 minus 2 pi r. So I'm going to substitute that for height over here in my volume equation. Volume equals pi r squared times 30 minus 2 pi r. Now if I'm going to do a derivative, I want to go ahead and distribute this pi r squared, so I don't have to do a product rule here. Let's get it simplified. So 30 pi r squared minus 2 pi squared r cubed. So that's a little weird, but it's just a number. So nothing to be concerned about there. Let's do a derivative. So this time, now notice here I don't have to do dv dt because the volume and the radius, they're not changing with respect to time. They don't depend on time. All we're doing is looking for a maximum volume. So I'm just going to call this v prime. And now I want to take this derivative. The derivative of 30 pi r squared is just going to be 60 pi r minus, and then this derivative, I've got r cubed here. This 2 pi squared is just a number. So I'm going to multiply the 3 and get 6 pi squared r squared. So now I've got my derivative. I need to set it equal to 0. And we're going to solve for r. So I'm going to factor out, it looks like we can factor out 6 pi r. And if we do that, I'm left with 10 minus, let's see, the 6 factored out, one of these pi's is left and one r is left, equals 0. So if 6 pi r equals 0, then r would have to be 0. But obviously, if our radius is 0, we're not going to have maximum volume. We're not going to have any volume at all if there's no radius. So that's not going to be the answer. Our answer is going to come from this factor. So 10 minus pi r equals 0. 10 equals pi r if I add pi r to the other side. And then divide by pi. So r equals 10 over pi. And does that answer my question? What is the radius of the one with maximum volume? Now, normally we would do a sign chart to make sure this is actually a maximum, but I don't have a choice that tells me there is no maximum. So we can assume that this is the radius that gives me the maximum, and that answer choice is E.